Okay, guys, let's continue where we left off. Um, so this is part two or part three memo. So we were talking about the delegation part. So with delegation, it's basically you delegating or or asking another class to provide you with its implementation. So for example, IoT scanner. We're gonna use IoT scanner as implementation because IoT scanner is good or it's very good with scanning, things like that, right? So that's what I'm going to do here. So since I'm calling IoT scanners implementation, right? Let's check IoT scanner. What does it take in? IoT scanner takes in an IIoT monitor, right? So since it takes in an II monitor reference, an address of IIoT monitor. So as we previously discussed, this operator, it returns a pointer, or basically it returns an IIoT monitor pointer, this. So it's basically like this. So it has that pointer there. That's why I'm getting this error that says no matching call to this function scan, a scan that takes in a an IoT monitor pointer. And as you can see, that's why it's even complaining that it failed to convert an IIoT monitor pointer to an IIoT monitor reference. So the way we get a reference, since it's expecting us to pass a reference, you can use the dereferencing approach. So by dereferencing, it means that I'm saying um, I want the address of this current instance. So when I use the dereferencing approach, I actually get the address, undefined reference to. Why is it saying that? Uh, build. Yeah, you see, that's the thing about this thing. I sometimes it just complains for no reason. It knew undefined reference. Oh, okay. I think I understand why it's saying undefined reference because we don't have it here inside of our class. So we don't have the implementation. So we need to do that so that it's because it's going to go to the IoT scanner class. Scanner classes both the header file and the CPP file or the implementation file. So what happened is that it only saw the function where it was declared, but it didn't see the implementation of that function. So that's why it's complaining. That's why it was complaining and saying undefined reference. So we needed to do this. So for now, in its mind, it's convinced that, okay, you did provide implementation. So I'm not going to shout at you. I'm not going to scream at you because I can see where the implementation is, right? So that's why it was complaining. So we have no errors. We've done the forward declaration. We've included the header files. Everything is correct. Everything is right on track, right? So let's implement the IoT scanner, right? Because we are using the scan. Let's implement the scan method inside the IoT scanner because we're going to call that implementation, right? So we need to implement the scan method. So let's check the scan method. Oh, okay, the pathway needs to know about the. Yeah, the part where it needs to know about the IoT scanner, it's basically the forward declaration. So we did that. So let's check the scan method, right? So the method must loop through all the sensors in the array, right? So let's loop through all the sensors in the array. So I'm going to do two for loops. Int r is equals to 0, r is less than. And then since I'm in the implementation file, I'm going to need a way of accessing the parameter. So I'm going to create a variable and call it obj monitor because I'm getting an object or an instance of IoT monitor. So I need to get the rows. I need to get the rows and the columns, right? So if I check, when I say dot, I don't have a means of accessing the rows and the columns. So since I don't have a means of accessing the rows and the columns, what I need to do is I need to create accessors for both the rows and the columns. So yeah, so basically an accessor is a way of me accessing the, the private variable, private member variables. So let me create accessors for it. So I want to access what these two things. An int for that represents the rows and another int that represents the columns. So let me do that. So I'm going to say int and then I'm going to prefix it with get. I'm going to put a prefix called get because I'm accessing, I'm getting something. And then followed by what I'm getting. What am I getting? I'm getting back rows. So I'm going to call it get rows like this. And then I'm also going to have an accessor for get calls. So with accessing, do you expect the user to change the data? When you're just accessing the data, you don't expect the user to change the data, right? So I'm going to add the const at the end, just like with the toString function. It was not changing anything. So I added a const suffix at the end. So const like this, because I'm not expecting the user to change the data, right? I'm just expecting them to just access the rows and the columns. And then I'm going to put in square bracket. And then I'm going to specify which class these functions are from. Basically, what I'm doing here, I'm binding. I'm binding the rows, the get rows implementation with the specific class. If I just leave it as get rows and columns, it doesn't, I'm not specifying where they belong to, right? So that means this class, it won't have implementation for the get rows and the get columns function. So what am I doing? I'm just getting back. So it expects me to return an integer, right? But what type of integer am I returning? I'm going to return the rows of this class. So I'm just going to say return underscore rows because I've called it underscore rows inside of my class, right? I'm just trying to access the private member variables. Remember, they are private, so they cannot be accessed directly. So what I'm going to do is I'm creating accessors for them. So what the accessor does, it's like it's you return that value, and then the value is going to be stored in it's this function is going to take a copy of that value. So rows is going to be stored in this function name as a copy. And as you can see, it's a copy that is the const. That means you cannot change the copy. And then I'm going to get back the columns again. And the columns are going to be stored inside this function name as get calls. And there's a const suffix, which means that you cannot change them. So now I have a way of accessing the rows and the columns, right? So let me access them. So get rows, there we go. Okay, before we access them like that, let's do this. Let me say semicolon row plus plus. And then let me say dot underscore rows. And another thing to pay attention to is the colors. When it says red, it's like a robot. It means no, you're not supposed to go. So you can't go there. So that means you cannot use anything that is the color red or a red square. So everything that's red basically means it's private. So you cannot use it. That's why I had to make an accessor for it. So if I say dot underscore rows, let me build, you're gonna see an error. It says what? Int underscore rows is private within this context. So you cannot access something that's private. It's inaccessible. You don't have that access. So what you can do is you can create an accessor for it. As you can see, the accessor is green. Green means that it's public. And then use that accessor instead. And then I'm going to do the same thing for my columns. So int c is equals to 0. C is less than obj monitor dot get calls C plus plus like this. And then I'm going to build. I won't have any errors. Yeah, because I am doing the right thing. If you don't do the right thing, you're gonna get errors. So I must loop through and check if any sensor, any of the sensors, right? So there's, as you can see, I need to have another accessor because what do I need that accessor for? For checking each sensor. So I need to get back this array. So I need to get back this array, right? So what I'm going to do, I'm going to create an accessor for it too. So get, I have the prefix get what? Sensor, like this, and then put a const at the end because I'm just getting the sensor. And then remember the sensor that it's two-dimensional. It expects two values, a row and a column, because we're trying to get a value at a time. Because yeah, we're trying to get a value at a time. So what I'm going to do is I'm going to provide two values for the row and the column. Remember that it's two-dimensional. So it expects two values, a row and a column. Then I'm going to go to IoT monitors, CPP file, and then add this function. And then I'm going to bind it to my class so that this implementation will be added as the implementation for the get sensor function. So I'm getting back a sensor, right? Return. So I'm going to use the keyword return sensors, that array. And then remember that I need a way to access these variables. So I'm going to say row and then column. And then I'm going to say turn the sensor at that specific row and column. Why am I doing this? Because the sensor is private. So what's going to happen is that it's going to return this, and then this is going to get that value and then use it as a copy. As you can see, there's restrictions to this copy. You cannot change it. Because for now, all I need to do is access, right? I need to access the date. That's all I need to do right now. So let me do that. So I need to access and check if they have a reading of 0 for either the temperature, the humidity, pressure, and intensity. So what I'm going to do is I'm going to do the if statement, right? And remember, I'm accessing the sensor for that current object that I'm getting as the parameter or as input of this function. So dot get sensor at that specific row. As you can see, it's showing me where the implementation is and how it looks, the parameters that I'm expected to pass, row and column, right? So what this means, this is equivalent, this is exactly the same, this line of code is exactly the same as me doing this, saying dot sensors like this are C. But I cannot do this because it's private. I can only access it through Oh, okay. My bad. I mean, I'm supposed to get back an IoT sensor, right? Not an integer. So I need to fix that here. Then it will start complaining about the actual error. You're trying to, yeah, now it's fine. So you're trying to access something that's private again. There's a problem. So what can we do? Use the access instead. So get sensor like that. Remember that a sensor is a sensor is of type IIoT sensor. That means the data type is the type of a thing of a reconstruction. So I can say dot again, right? So dot what? Temperature, and check if that is equals to 0, because we're checking if all the sensors have a reading of 0. That's why I'm doing that. So is equals to 0, or it says all of them. And then if any of the readings is 0. So if any of them, so since they said if any, I'm going to use the or operator, because that means I can have more than one, but not necessarily all of them. Dot get sensor rc dot int humidity is equals to 0. Remember the temperature is a double, so I'm just going to say dot 0. You don't necessarily have to write that, so it's not a necessity, because it will cast it to a double, but just need to be specific. So dBl pressure, that's a double, so 0.0. And then obj monitor dot get sensor, specific row and column dot dBl intensity, that's also a double, 0.0. There we go. So we've checked if any of them is a double. Is it, no, not is a double, is equals to 0. If any of them is equals to 0. So once we've checked, what must we do? We must set the sensor to be inactive. So as you can see, we're gonna need an extra function, which is a setter or mutator. Because what are we doing right now? We're supposed to mutate the data or change the data. So I'm going to create a mutator for it. So mutator. So remember that the mutator just doesn't return anything, because I'm just meant to just change the data. So I'm going to prefix it with set, because I'm setting the data, right? So set what am I setting? A sensor. So set sensor, and I don't put the const there at the end, because it is actually meant to change the data. The data shouldn't be constant. So it's going to take in two things, a row and a column, right? And the value that I'm setting it to. So the value that I'm setting it to, I'm basically updating the IoT sensor, and I'm updating the is active part. So with this active, there's many ways you can do it. You can take in an IoT sensor like this, or you can take in a Boolean. You can do that. You can take in a Boolean or an IoT sensor. So I'm just going to show an example of us using the IIoT sensor and also using a Boolean. There's two ways you can approach it. So I'm going to do this to bind it with the class, so that the class will take this functions, will implement that function. So it must suppose to take in three things, right? I'm going to take in a row, that specific row, and a column, and a sensor, right? And then I'm going to say sensors, my two-dimensional array, that specific row and specific column is equals to that new sensor, because that's what it's supposed to do. We must I must update the sensor, right? So once I've created a setter for it, I'm going to use it this side. I'm going to say obj monitor dot, because I'm not allowed to do this. I'm not allowed to say dot sensors is equals to something, right? I'm not allowed to do this because at first things first, this says private. And if I try using the accessor and then setting the value, remember the accessor is not meant to mutate the value. It's just meant for you to get back the value. So I'm just going to do that. So dot set sensor, that specific row and column is equals to this new sensor, is equals to that new sensor, right? So now the problem is if I pass in a sensor, right, it becomes a problem because now how am I going to change the sensor? I mean, I could technically do this. I could say IoT sensor like this, and then say sensor, and then say is equals to obj monitor dot get sensor, right? And then after getting the sensor, I say sensor dot is active is equals to true. I could do this. You see, it's going to work. I can do this. But I don't want to have lots, I don't want to have extra lines of code, and I don't want you guys to be confused and be like, okay, but you said the sensor cannot be changed when you're using the get sensor function, but here you're changing it. Yeah, I would rather pass it as a Boolean instead of an IoT sense. So I'm just gonna pass a Boolean there and then change this to a Boolean. And then I'm going to call this is active because I'm changing the is active, right? So now, since I'm using a Boolean, I need to access the is active directly. So I need to say dot is active. And then I only change that is active, right? Because that's what I'm supposed to change. Then I go inside, as you can see, now it has changed. It's a bit different. And then now I'm going to go to my IIoT scanner and remove these two lines of code. And then here, it's no longer expecting a sensor, right, as the third parameter. It now expects a Boolean. So I'm going to pass true. As you can see, now it expects a Boolean. So I'm going to say comma, and there we go. It expects a Boolean is active. I called it is active. So it needs to be false. Yeah, false, not true. Because they said you should set it to inactive. By inactive, it means that it needs to be false. And then, boom, that's it. We are done implementing it. That's all you had to do. So now I need to go inside my main and then call the scan function. So I need to scan before displaying. So let me do this. So I'm still going to use the default constructor. So after creating an instance, here I'm creating an instance of the class. Basically, I'm creating an object. So after doing that, now I need to scan. So obj monitor dot scan. And there's this code that I'm going to get. The code is being done for me by the IIoT scanner because I've delegated my task to IIoT scanner. So IIoT scanner is the one that's going to do the things for me. So and you can see here, there's no, your main doesn't know about IIoT scanner. So you can imagine your main is like your teacher. and you copied your homework. So obviously your teacher's not gonna know that you didn't do it yourself, right? They're just going to see and be like, okay, also this is what you got for marks. Okay, well, I'm proud of you, you're improving. But the truth of the matter is that you actually copied from someone. Someone else did this thing on your behalf. So that's what delegation is all about. So we're going to scan here, but I'm not good. The IoT monitor is not going to be the one that scans. It's the IoT scanner, but the user doesn't have to know about that. And then I'm going to build and run again. Oh, okay. The the minimum, the random value. Remember that the default constructor uses defaults. So I happen to have a default that's out of bounds. This one. So it needs to be 30,000. And remember that this is the min light is a double, so I need to put a dot zero there so that it makes sense why so that it makes sense why I use the const expression. If I just leave the dot zero, that means I'm saying it's an integer. So and that means I don't have to use the const expression, rather use a const keyword only. As you can see, the integer doesn't have more than one value. It's just one integer. It's not followed by dot and another zero. You see, it only has one value or one thing. And then I'm going to build and run again. There we go. But we are not done with our method. There's this method, the the toString method. We need to update it because now we no longer have the int sensor ID, right? So let's do that. As you can see, this one is X values. So we need to account for that. So the toString memo function must be updated so that the inactive sensors are represented by the character X. So the inactive sensors are represented by the character X. Let me see. And we still have M. And yeah, we still have M and all the other ones. So that means everything is still going as usual. But then I also just need to add the is active. So what I can do is I can do it like this. I can say bool is active. And then I say sensors that specific row and column dot is active like this. At the top, I store that value. And then it says if we only need to display if they are inactive, right? So inactive, it means that it's the negation of is active. So I need to negate it just like I did here. So I need to do the very same thing. So what I'm going to do is before I even display all the other ones, I'm going to start by checking if it's is active. Because if we check here, so instead of displaying any of the characters, I'm going to display X. So instead of displaying, let me see, if more than one, oh, okay. So before I even display the more than one if statement, even before that, I need to check if is active first, because that's the one that is higher priority. So if it's active, and I'm trying to check if it's not active. So if it's not active, and then I'm going to have else if. So else if I'm going to have the else if. So after checking if it's not active, if this fails, then I can check the rest the way I was normally checking, right? So let me do that. So if it's active, before I check others, I need to check if it's active. If it's not active, then display X followed by a space. So that's all I needed to add here. Yeah, that's all I needed to add. All the other ones still need to be displayed. But before I display others, if more than one is active, I check if it's active at all. If it's not active, I check if it's not active. If it's not active, then I don't bother displaying the other ones because it's not active. So now I'm going to build and run. There we go. Now there's X values. Sometimes there's X values, sometimes there's the normal ones, which is the expected output. So that's it for practical 2. That's all you had to do. So now I'm just going to stop this recording and then do the recording for prac 3, for prac 4, I mean.